Welcome students, I am Usha Rani, working as assistant professor in the department of CSBS in Ramco Institute of Technology. In this session, I am going to explain the conversion of generic tree to binary tree. Before getting into the session, we have to know two things: what is generic tree and what is binary tree. So as we know already what is binary tree, so we will recall that. So what is binary tree? The tree, it is a hierarchical data structure in which each node can have at most two children. So referred to as left side and right side. So it is this data structure is commonly used in computer science for efficient storage and retrieval of data with various operations such as insertion, deletion, and traversal. So we can see the example on the right side. So two's left child is 7, right child is 5. Similarly, 7's left child is 2 and right child is 6. So like that, a node can have at most two children. So children of 2 is 7 and 5. Similarly, we can also see what is generic tree. So generic tree is a collection of nodes where each node is a data structure that consists of records and list of references to its children. So already we know linked list. In linked list is collection of nodes in which each node consists of two parts. The first one is data part and the second one is address part. So data part contains the record and address part contains the reference to the next node. Similarly, in generic tree, each node consists of two parts. So first one is record part. So next one is list of references to its children. So there are some properties of generic tree. So first one is it can have many children at every node. So if you see the example in the right side, so node A has many children, right? B, C, D, E, F, G. So similarly, each node can have multiple children. So the second property is the number of nodes for each node is not known in advance. So it may have any number of nodes, but we doesn't know in advance. So if you are see the example of generic tree, so node A has 6 children, node D has INJ 2 children, right? So this is an example of generic tree. Now we have to see the rules of conversion of generic tree to binary tree. So rules to convert generic tree to binary tree. The first one is the root of the binary tree is the root of generic tree. So in the conversion, both are having same root. Okay. So second rule, the left child of a node in the generic tree is the left child of that node in the binary tree. So there is no change in the left child of the node in generic tree as well as in binary tree. The third rule is the right sibling of any node in the generic tree is the right child of that node in the binary tree. So first we have to know what is sibling. So sibling is a nodes having same parent is called sibling. So if it is a right sibling means, so for example, if you see that example, A's child are B, C, D. So B siblings are C and D. What is right sibling means? B's right sibling is C, C's right sibling is D. D's left sibling is C, C's left sibling is B. So now I think now you can understand what is right sibling. So now see the rule number 3. The right sibling of any node in the generic tree will be considered as the right child of that node in the binary tree. So now we move into the problem. So let's consider the given example as a question. So A's children are B, C, D and B's children is E. C has 3 children, F, G, H and D has 2, I and J and J's children is K. So now this is a generic tree, because each node is having multiple children. So we have to convert this generic tree into binary tree. Now take rule number 1. As per the rule number 1, the root of binary tree is the root of generic tree. So I am considering A as the root of binary tree. Right? A is the root of binary tree. So both the roots are same. So next thing is A's left child. A's left child is B, right? So see the second rule. the left child of a node in a generic tree is the left child of the node in the binary tree. So B is the left child of A. So that will be considered as left child in binary tree also. So step number 2, B is considered as left child of A, right? So next, B's left child, as per the rule number 2, B's left child is E. So that is, we can consider as the left child of B in binary tree also. So next thing is, B's right sibling is considered as the right child of that node. So B's right sibling is C. So that is added as right child of B in binary tree. So next, so C's left child is leftmost child. C is having three child in generic tree F G H, in which the leftmost child is F. So that will be considered as left child of C in binary tree. Then what is C's right sibling? D is the right sibling of C. So that is considered as the right child node in binary tree. So in next step, D's left child is I. So um, that is considered as D's left child in binary tree also. And D doesn't have any right sibling. So no need to put right child for D. So now consider I. So I I has I doesn't have any children in generic tree, so there is no left child. But I has right sibling, right? So right sibling of I is J. So we can put right child of I is J. So right child of I is J. So now K is left child of J. So directly we can add K into left child of J. So now the remaining nodes we have to see. So if you consider there is no left child, and there is no sibling, right? So that is not a problem. In F, if you consider F, it doesn't have any children, so there is no left child, but it has G, right? G as right sibling. So we have to put G as right child of node F in binary tree. So F's right child is G. So if you see the generic tree, G's right child is H. So right child of G is H in binary tree. So we have go through all the nodes in the generic tree and converted it into the binary tree. So it's very simple. We have to remain three roots. So first one is root of the binary tree is root of the generic tree. Then left child of a node in generic tree is the left child of node in binary tree. And third rule is the right sibling of any node in the generic tree is the right child of node in binary tree. So with that, the question has been solved. So I have given some practice problems on the same pattern. So try to solve these questions and post it in the comment section. So thank you for listening this session.